guys, this is the homework section from 11.2 Binomial, and a few of you contacted me about not understanding this section well, so I thought I'll just go over the homework together. The first three questions are similar in what you need to answer because it's asking if the setup is binomial. And if it is a binomial, then you have to find NPQ. And if it's not, you have to explain why. So let's review what binomial was. So the binomial, there are a couple conditions that you have to follow. So like first one was that there are two outcomes, right? There are success and failure. And then the second one is that the probability P, the probability of success, stays the same. And that you have to have a fixed number n. So like you couldn't say like, oh, I'm going to ask people until I find like how many people. It was like, oh, I'm going to ask n amount of people before you start, right? So let's go into 13. It says you surveyed 25 students. So that is an n, right? Because you already determined how many students that you're going to ask. And then you're going to determine, you're going to find out how many are left-handed. So we have to assume there is no, what is it? What's the word? Ambidextrous? Like people who can use both hands. Assume that there are only left and right-handed person. So I'm assuming that there will be no one who can use both hands, okay? Because if there are people who can use both hands, it's kind of hard to say it's a binomial. Or else I will assume that that person can just be left-handed, right? So the success would be defined as a left-handed person. And then the failure will be determined as right-handed person, right? So then the random variable x can be anywhere from 0 to 25 people, right? Although it's very unlikely that you could have all 25 people left-handed. What about probability? Well, since there are only two outcomes, either left or right, it's going to be 0.5. And Q will be also 0.5 because it's 1 minus P. Okay? Obviously, yeah, and that's it. So that's number 13. So let's go to 15. You roll a die 10 times to see if a 5 appears. So, okay, this sounds like a binomial setup. Your n is 10, and your success is seeing 5. So even though there are 6 possibilities, everything else can be considered as failure. That means this is still a binomial. Okay. And then the P, probability of P would be 1 over 6. And then Q would be 5 over 6 because there are 5 outcomes out of 6. That is not 5. So the random variable x can be anywhere from 0 to, again, 10. Because you're doing 10 times, so you can see 0 amount of 5 when you roll 10 times. And you can see 10 5s when you roll 10 times, right? What did I do? I'm trying to use a stylus, and it's not exactly most high quality. I just found it in my pencil case. So it's actually, I'm not so sure if it's working well. Alright, 17. You ask 15 people how old they are. Okay, so this is good that you have n, but how are you going to set this up as a binomial? How old they are? That's very, like, I just want to see. So this, I wouldn't consider this as a binomial, so not a binomial, just because you don't have, if you said something like, you want to ask 15 people and count how many people were 18 years old, then everything else would be considered as failure. So you could have a binomial, although coming up with P would be a little bit difficult because like you will have to find who is the oldest person kind of thing. So this one, it's not a binomial because there is no clear success. What would be the success? And therefore there'll be no clear failure either. So it's not something you can write as success and failure, so therefore it's not binomial. All right, 21 and 23 is constructing a graph of the binomial distribution. So let's look at 21. 21 is actually longer because it's a month of the year. All right, so we know, so we assume that this is not a leap year. This is because a leap year, February would have a different number of days. Oh, yikes. I hope you can see. Alright, so this is not a leap year, which means that there will be 28 days. And then probability of success is 0.23 because it says find how many sunny days in February. So then the probability of failure would be 1 minus 0.23, which is 0.77. Okay. So this one, let's create the table because that's the easiest. So x goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and all the way to 28. Do you see why I said this is a long problem? Let me pull out Excel here. Alright, so I just have a Excel. So P is 0.23 and then Q is 0.77, right? And then we have number of days, 0, because you could have a 0 day of sunny days, all the way to 28. Oh. And then I'm going to find the probability. And if you remember the formula went, it was like NCR times P to the R times Q to the 1 minus R. Okay, so let's just use that formula. So combination. So let's do combination first because I want to make this as simple as possible. I think there are 28 and I'm choosing 0. Alright, so then I'm just going to apply this. Alright, 28. And then I'm going to choose this. And then I'm going to reapply this to be like this. Hopefully that works. Alright, great. This worked. Perfect. Alright, so then I'm going to do P of X. And then what I'm going to do is I'm going to do this times P to the R times Q to 28 minus R. Sorry, I wrote that question, I wrote the thingy wrong. It should be N. It should be N. Oh. Sorry, P is supposed to be 0.23 and Q is 0.77. So let's do this. And then I'm going to just drag this because that's why I wanted to do Excel. It does everything for me if I write the functions correctly. So here it is. These are my, what's it called? Probabilities. And you can see it's very small. Okay, so I created the chart using insert 2D bar chart here, this one. And then, as you can see, that it peaks around like 7, right? Although this kind of seems not right. Oh, maybe it's not right. Let me fix this problem here. Okay, I fixed it. This. And remember, this one also wanted you to find the expected value. So what you do is that you multiply the x value with the probability of that, right? And so I'm going to do that for all of them. And here. And then what I can do is that, well, I have to do sum of. So I'm going to do sum of this entire column. So I get 6.44. So that means is that my average is about 6.44. Okay. And then what was the standard deviation? You also had to find it. And let me get this right. For standard deviation, you do NP cubed. So N is 28. P is 0.3, Q is 0.677. Sorry, that's the variance, right? And standard deviation is the square root of that value right there. So this is a standard deviation, and this is the mean. So that's number 21. 23, it says 65% of students wear a seatbelt. So let's say P is 65. Then Q is 1 minus 65, which is 0.35. And they ask 8 people at random, so N is 8. So to make this table, I guess we still need to do X and P of X. And then do 0, 1, 2, 3, 4, 5, 6, 7, 8. Although this is less than the other one, I will still use the Excel because that's the fastest. Alright, so this is what I did, just like the last time. I found the combination first, and then I used those numbers to find the probability. So then to find the graph of this, this is not the right graph. We have to select data. So I'm going to select data of P of X, and then, sorry, this is not right. Edit. And I'm going to choose each value. Okay, and then we also need to edit this because it actually starts from 0, not 1. Alright, so this is your distribution for this one. We need to find the mean. So it's 8 times 0.65. Last time I showed you how to find expected value by doing it, but because this is binomial, you can just use the formula, which is NP. So this is the mean, and then the variance would be NP cubed, so 8 times 0.65 times 0.35. Oh. And then standard deviation would be square root of this guy. So standard deviation. And that's it for 23. So, I mean, I think you would have taken a lot of time if you use a calculator. Excel is a great tool that you just need to kind of figure out. If you know Excel, there are a lot of things that you can do easier and faster than your peers, basically. So, yeah, that's it. And I'm going to go over 25 and 26 in the next video because I ran out of time. So, here it is.